Hi, my name is Mr. Evangelista, and in this video we're going to be calculating velocity. Now if you remember, the way we calculate, let's talk about speed first. The way we calculate average speed is we take the total distance traveled divided by the total time it took to travel that distance. Now velocity is very similar. However, instead of dealing with distance, which remember is the total path traveled, right? Distance is the total path traveled. We're going to talk about displacement. So it's the final position minus the initial position. If you remember, that's displacement divided by the total time. So again, speed and velocity are very similar. It's just the only difference is that velocity cares about the direction. So if we're traveling to the left, the velocity is negative. If we're traveling to the right, the velocity is positive. Speed does not care about the direction. So it doesn't matter if I'm traveling left or right, it's just a number without positives or negatives. Okay. So let's take a look at an example of something moving, and let's see if we can't calculate the velocity of it. Okay, so we just saw a video of a toy car, and let's try to calculate its velocity. To do that, we need some numbers. So the initial position of the car was 0 meters. The final position of the car was at 1 meter because it traveled 1 meter stick. Now the initial time was 34.4 seconds, and the final time was 37.2 seconds. If you remember from the previous slide, if we're going to calculate the average velocity, we're going to have to take displacement, which is the final position minus the initial position, divided by the change in time. So let's calculate the displacement. Our final position was 1, our initial position was 0. And we're going to divide that by our change in time. The final time was 37.2, and the initial time was 34.4. And so 1 minus 0 is 1. Divide that by 37.2 minus 34.4 is 2.8. And we get about 0.36 meters per second. That means every second while the car was traveling, it would move about 0.36 meters. So after 1 second, it would be at 0.36. After 2 seconds, it would be at 0.72, and so on and so forth. So we're moving this many meters every second. Let's take a look at another car. Okay, so let's calculate the velocity of the second car we saw. Here are the data numbers, and here's our equation. So let's calculate. We do the final position minus the initial position for the displacement. We divide that by the final time minus the initial time. Okay. And we get 3 divided by 3.1, which is about 0.97 meters. Very close to 1 meter every second. Okay. That means for every second, this car travels about 1 meter.